All right, so we're going to look at area comparison theorem, and all of these are going to seem really basic when you look at them. Let's say you have two triangles that have the same base b. This is b, the base, and obviously they have different heights. So if you find the area of those, the top one, 1/2 base times height 1, the bottom one, 1/2 base times height 2, you can see the 1/2s, the b's cancel. It's the ratio of the heights. So what they're saying is if the bases are equal, then the areas are proportional. Okay, let's see if that works for heights. Here's height, but the bases are different. So it's 1/2 base 1 times height, 1/2 base 2 times height is that area. Well, of course, the 1/2s and the h's cancel, and you get b1 over b2. So the bases, the altitudes are going to be, or the areas will be proportional. If you have equal heights and proportional altitudes. Okay, so the triangles will be proportional to the altitudes if the altitude, or if the heights, bases are equal. They'll be proportional to the bases if the altitudes are equal. I know that kind of makes sense, but the wording is a little clunky. So let's say you have two triangles. You have side A, B, and then it's proportional, KA, KB. But the angles are going to be the same, but these triangles are similar to each other. What does that do if they're similar triangles, but they're different areas? Well, remember way back when, let's go make a little height here. What's the sine of theta equal to in terms of h and a? You have height opposite, hypotenuse A won't just be h over a. So h is a sine theta. So therefore we can say the area is going to be 1/2 AB sine theta. For this one, same thing, it's going to be 1/2 BK times KA sine theta. So 1/2 KA KB sine theta. The halves will cancel, the sine thetas will cancel, and the ABs are even going to cancel, leaving K squared. Now, if you multiply top and bottom by A squared, you're going to get KA squared over A squared, which is just this side to this side. AB is to PQ, but they're squared now. So what they're saying here is that the squares of the corresponding triangles are similar. So areas are proportional, and the corresponding sides are proportional. So with that in mind, we're going to get to these problems, and these are going to bend your mind a little bit. It says in triangle ABC, P divides BC into a ratio of 1 to 2. Would you write that in? And AC is divided, Q is the midpoint of AC, so that means this is 1 to 1. And then R divides AP into 2 to 5. How are we doing? Doing all right? All right. So we want to find the area comparison of this little gray to this big one. Now, you'd think this would be the easiest thing ever, but it's actually kind of tricky. So what happens here is that you have to look at these triangles, and these sides are set up as a ratio, and you have to find equal height triangles. So the heights are going to be of these two, these have the same height. So therefore, the bases are proportional, and so are the areas. So if the bases are 2 to 5, what are the areas going to be? One more time. Same heights. This purple triangle and the green one have the same height. It's kind of a weird. How do you know they're the same height? You can extend this line out and look at the height of this purple one.
Oh, I see.
It's not super obvious, I don't think. But the green one and the purple one have the same height. So since the heights are equal, the bases are proportional, so the areas are proportional. The bases are 2 to 5, the areas will be 2 to 5. The key is finding that these are equal areas, 2 to 5, okay? So now we've got those, okay? Now I'm going to do another one, and I'm going to take this triangle down here that has this height, and I'm going to take this blue triangle here that has the exact same height. So the purple one and the blue one have the same height. So therefore, these two add up to 7x. What does this one have to be if these are 1 to 1? If the bases are 1 to 1, what do the areas have to be? 1 to 1. So 2x plus 5x is going to give you 7x. This 7x has to balance this 7x. How are you doing? I told you this the formulas are easy, but the application of it is a little tough. And then we have two more. And those will be this one here. I'm going to take this height, extend this out. This height, 3, if you want to call it that. And then I'm going to compare it to this guy here. Okay, this is 1 to 2. This has a total of 12 plus 2, 14x. What will this one have to be then? 7x. So finishing this off, this is 7x. So therefore, what you're going to get is 5x is to what? Yep. So triangle PQR is 5x is to 21x, which is 5 to 21. Aren't those fun? All right. And you can try these. Now you'll be able to do these last ones, number 6. Did I have 5? Yeah, we did that one already. 6 and 7 and 8. Ought to take care of it for tomorrow. I will check those tomorrow as well.